Alright, so here we are, the last of the videos for Chapter 5. And in this one we're going to talk about burns, classifying burns, and then looking at how we recover from burns. So let's dive right in. So burns can be caused by a number of different factors. It could be because of direct exposure to heat, like a flame or a hot object, boiling water, grease, whatever it is. Or it could be because of exposure to certain chemicals that are either very acidic or very basic and therefore can damage the skin. Electricity can cause burns, and radiation, including UV radiation that we see or that we have in sunlight, can cause burns. And serious burns are a threat to life for a couple of reasons. The first is that when we break through the epidermal surface, we lose the waterproofing of the body, and so the loss of fluids and the loss of associated proteins and electrolytes that are in plasma and lymph and other body fluids, that extracellular fluid, it's all, the risk of drying out is very great. And then second, because we've broken through that epithelial surface, then we have lost our primary means for preventing infection. And so the burn point, or burned area, is a easy point of entry for pathogens. So let's look at how we classify burns. The first burn type is called a superficial partial thickness burn. It's superficial partial thickness because it doesn't burn entirely through the skin layers. It only causes damage to the epidermis. And so it's the result of of overexposure to the sun. So a mild sunburn would be an example of a superficial partial thickness burn. Being scalded by a little hot water, coming into brief contact with a hot object, or really harsh chemicals can all cause these superficial partial thickness burns. There is another way of classifying burns that was less descriptive, and so this means that we use now, describing, tells us exactly what tissues are involved in the burn. And so that's why there's been a migration toward a more descriptive means of talking about or classifying burns rather than the old school first degree, second degree, third degree burn. So in a superficial partial thickness burn, the skin is dry, so it's not moist or weepy, and may become red and painful, but there are no blisters. So blistering would be a sign of a deep partial thickness burn. But there might be some minor edema, so we could see some swelling. Edema, hopefully you remember, it means swelling. And healing can be fairly rapid, just a few days, if it's a minor, very, very minor burn. Or it may take a week or two. But usually there's no scarring because there is plenty of epidermis around, or epidermal tissues around, and the stem cells in that epidermal tissue will invade into the burn area, and we'll see healing fairly rapidly. Okay, so superficial partial thickness burns, they are the least damaging of the burn classifications. The second kind of burn, or second more serious burn, is a deep partial thickness burn. So this is a burn that goes through the epidermal layer, and so we see destruction of the epidermis, and then damage, but maybe not complete destruction, in the dermal zone. So it's a deep partial thickness burn. And it's caused by longer contact with hot objects, like grabbing a hold of a skillet that's still really hot from being in the oven, perhaps, or sitting on the stove getting hot, or having longer contact with liquids like grease or water or flame, or actually having clothing burn while you're wearing it can result in deep partial thickness burns. And in the case of a deep partial thickness burn, it might be a really deep red, or if there's been enough damage to the capillaries, then there might be no blood flow at all, and so it becomes a waxy white color. It'll be moist and weepy, firm, so there'll be some significant edema in the area. And this is because of the damage to the capillaries there. And there may be so damaged that fluids begin to escape out of the capillaries and come bubbling to the surface underneath the epidermis, or nearby epidermis, and that forms blisters. So blistering is a characteristic of deep partial thickness burns because of the damage that's done down there in the dermal region, destroying those or damaging capillaries. And with deep partial thickness burns, because of the epithelial tissue has been destroyed, we depend on epithelial recovery from the stem cells that are associated with the accessory structures that are deep in the dermis. So if this is the skin surface, and here we have a hair follicle, so here's the surface, the epidermal areas with the stem cells here at the basement membrane. Remember, there are also epidermal cells with stem cells here too. And so if we burn this area and maybe burn into the dermis some, we still have the deep areas of the hair follicle that allows for recovery. And so these stem cells, as this area recovers and we see new connective tissue filling in the burned area, these stem cells can swarm up and over and cover. Now you can't see. I wish I had a different color to use, but the stem cells will swarm up and form a new epidermal layer as that area heals. And as long as there's no significant infection in the burn, then usually there's no scarring because the epidermal tissues will be able to just kind of cover it over and do just fine. Where scarring occurs is when we see connective tissue fibers at the surface of a skin. So if we have a wound here and there's no epidermal tissues, then that's what creates the scar. And so you see this really tough tissue that comes and fills in that area. And there's no epidermis, so the epidermis would end here and start again on this side. Then at the skin surface, this would be where the scar is. So unless there's a really nasty infection that does some damage to the epidermal tissues around the follicle or whatever that deep structure is that has stem cells, then we don't expect to see much scarring. And then the last kind of burn is called a full thickness burn. Full thickness burns occur after immersion in hot liquids or prolonged exposure to hot objects or to flames or corrosive chemicals. And with full thickness burns, we destroy both the epidermis and the dermis, as well as all the accessory structures in that region. And then we can even damage the deeper subcutaneous layer or the underlying muscle, bone, and nerves. And so these are really significant burns where the skin is removed or has been completely destroyed, and we might even get deeper into the deep tissues of the body. The skin, what's left of it, becomes very dry and leathery. It's been killed. It may be reddish, it could be white, or if it's really been charred, it may be black. And depending on the level of destruction, and this is an interesting thing, these full thickness burns are either extremely painful because of the just ravage that's been done to the nerve endings that are in the dermis and the subcutaneous layers, or they'll be mostly painless because the nerve endings have been completely destroyed. And so the cells, the nerve cells, they've got no receptor out there starting a signal. And so it's a bizarre thing to think about these really significant burns actually being somewhat painless. Any full thickness burn requires immediate medical attention, again, because of the risk of infection and the water loss. And generally, it's not just a small burn when a full thickness burn occurs. This is a burn that is covering usually large areas of the body. And healing is a lot more challenging because healing can only occur from the burn margin. So scarring, in the case of a full-thickness burn, is very significant. And if the really large patch has been burned, then grafting or bringing in other tissue to cover that area may be required in order to get recovery, to any kind of degree at all. So let's talk a little bit about grafts. Grafting is a surgical procedure where tissue or where a skin substitute is placed on a burn or even on wounds that aren't healing properly. And the graft may be permanent or it might be a temporary graft to cover a wound or damaged skin. And grafts are used there to protect from fluid loss, to preserve the deeper tissues because you want to cover them over, keep them moist, prevent them from becoming seriously damaged too, if possible. Assist in regulating body temperature, because without the skin, it becomes harder to regulate body temperature, of course. And then to prevent infection. So where do we get grafts from? What are the sources of grafts in the body? Well, there are multiple sources. The best source, though, is to use the patient's own skin, because this can be a permanent transplant of skin to the damaged site that will then allow the most complete healing to occur. So autografts, like autobiography, means self. So an autograft is a graft that comes from the person who's been injured. An allograft is use of somebody else's skin. So because usually we don't have skin donors among people, the skin that winds up being used is from a dead body, but it can serve as a temporary covering to allow wound healing to begin, and then once recovery has begun, perhaps an autograft can be used later on. And then last of all, there are skin substitutes, and there's lots of things that can be used. I say lots, but there are a number of items that can be used. One is the amniotic membrane from a recently born baby, or artificial membranes have been developed that can be laid over the wound or the burned area and remain there until an autograft can be done. And then finally, and this is the most exciting, is that in the past couple of decades, we have gotten better at culturing human epithelial cells. And now there are processes that can produce fairly large sheets of epithelium. And it can be done quickly enough, even from the patient's own skin cells. And so by growing out human epithelial cells in large sheets, they use drums that rotate through a saline solution. Round and round they go to keep the epithelial cells moist and to allow them to grow on a fairly large flat surface. And then that can be laying over the wound as it begins to heal. And those, because it's the person's own skin, they can take hold there and be used to cover over and grow over that area. Okay, so the last of the important things that I wanted to cover in this chapter is looking at how you estimate the extent of a burn. And it's important to be able to do this because you want to be able to know how much fluids or how much electrolyte material to replace that's being lost through evaporation directly from the burned area. And so the easiest way to come up with a fairly accurate estimate of the extent of the burn is called the rule of nines. And so by dividing the body into 11 regions, each of which is either 9% of the body or a multiple of 9%, we can do a pretty good job of estimating the percentage coverage of a burn. So the head, the entire head, is about 9% of the surface of the body. The anterior surface of so the face and front neck, and this is head and neck, I should say. So the head and neck, anterior surface is about 4.5%, the posterior surface 4.5%. Add those together, that equals 9. Each of the arms is about 9% of the body. So once again, anterior would be 4.5%, posterior 4.5% too. The anterior surface of each leg is 9%, so 9% plus 9% for the anterior surface. Posterior is 9%, and then of course your other leg would be 9%. Or if you wanted to say an entire leg, then an entire leg would be, think about it for a minute, turn off the video if you have to. Okay, if you're back with me now, an entire leg would be 18%. You just add together the anterior of one leg, of the leg, and then the posterior of the leg. The anterior surface of the trunk is like two anterior surfaces of a leg. They're 18% as well. The posterior of the trunk, 18%. So if you add all that up, you should equal 99%, leaving the genital region to be about 1% of the body. And so on the exam, I want you to expect to know, or to have to determine how much of the body is affected by a burn. And so I've got 3 sample problems for you to do here. So the first one is, what percentage of the body is affected if an adult suffers burns to the anterior head, entire right arm, entire anterior trunk, and the anterior right leg? So that's the first one. Here's the second. What percentage of the body is affected if an adult suffers burns to the entire posterior trunk, the genital region, and the entire right leg? So let's go back and take a look at the first question. You may want to turn off your video now and sit and do the problem on your own page and then come back. Okay, so I'm going to assume that you're back with me. You've already done the problem. Let's check in to see how you did. So what we said was that we have just the anterior head. So I always like to draw out my dude. It helps me just make sure I've got it. So it's the anterior head, the entire right arm, so the anterior and the posterior right arm, the entire anterior trunk, so that's involved, and just the anterior right leg. So the anterior surface of the head is 4.5%. The entire arm would be 4.5 plus 4.5, or a total of 9%. The entire anterior trunk, that would be 18%. And then finally, the anterior right leg would be 9%. So we add all this together, and you should get an answer of 40.5%. And let's say for a moment that I had added in the genital region, then that would add another 1%, and that would be 41.5%. So there we are. First one, hopefully you got that right. If not, then maybe you want to pause and look again at your second one and see if you can figure out whether it's right or not. And so I'm going to move on. And if you're back with me now, let's take a look. We've got, again, an adult who suffers. This is a burning person, I guess. Burns to the entire posterior trunk. Okay, so we got the posterior trunk, the genital region, and the entire right leg. Front and back. So the entire posterior trunk would be 18%. Genital region, we'd add in 1%. And then the front and the back of the right leg, the anterior and posterior back leg, would be 9 plus 9. So that comes to a total of 37. So 37%. Hopefully you got both of those right. If you didn't, go back and look at the rules again, and hopefully you'll get it. And if not, check with me. You can always check in with me before the exam starts, and we can go over this process again. Now, I gave you in your notes the rules for a child, if a child suffers burns. And so let's do one of those. So we're going to draw a little baby. And as I put in the notes, the reason that children have a slightly different set of rules is because relative to the rest of the body, babies' heads are very large. You know that, or hopefully, if you've had a child or if you've played with them, you know that little babies, you can take their little hands and they barely meet over the top of their head. Now do that with yourself. Hold your hands up so that they meet over the top of your head. Can you see now, if a baby's hands can barely meet over the top of their head, how much larger their head is than the rest of their body, relatively speaking. And so we have to give a greater percentage to the head. Notice that the head is worth 18% of the whole body rather than 9% of the whole body. And then we subtract that from the lower limbs. The 9% that would have been that is now accounted for in the head comes from the legs. So the question is, if we suffer a burn to the anterior head, the entire right arm, so front and back, the entire trunk, front and back. Oh, poor little baby. I'm sad because we've burned this fella significantly. And then let's see, the anterior right leg. You know what? I have been marking the wrong legs and the wrong arms. Oh, that humiliations galore. I was not using making the patient, so I apologize for that. You can subtract as many anatomy and physiology points from me as you wish. Okay, so let's look at the head. It's worth 9%. The entire trunk is worth 36%. So just like in the adult, 18 for the anterior and 18 for the posterior. Upper limb is worth 9%. And then the lower limb is worth 13.5%. Oh, and I made it tricky. I should have just said the entire right leg, but I didn't, the anterior right leg. So 13.5%. We have to divide that into 2. That's 6.5 plus. So that's 6.75. That's way too particular. But we're going to go ahead and leave that. So we'll add 6.75 is for just the anterior surface of the right leg. So we add this all up. We have, let's see, that would be 45, 54, plus 6 is 60.75%. I will let you use your phone as a calculator on the exam, or I'll have it. I've got a calculator that you can use as well. So if you're not comfortable with doing the addition, I've really not that messy. It should be 60.75%. If you're not comfortable with doing the addition on your own, then yes, I will allow you to use your cell phone as a calculator. So there we have it. So in the chapter 6, here are some of the things that we've done. We talked about what it means to be an organ, and we've talked about the organ that makes up the integumentary system, the skin, and we've talked about functions of the skin. We've described the structures of the layers of the skin, both the epidermal layer, the dermal layer, and the subcutaneous layer. We've talked about what it is that causes skin to have the color that it has. We looked at the accessory structures of the skin and talked about their functions. We've explained how the skin is involved in the regulation of body temperature, talked about wounds and burns and how they heal, and then we distinguished amongst the burns and helped to describe how each of them heals. And then your job will be to go through and read the other parts of the chapter and to summarize lifespan changes as relates to the integumentary system. So good job, you've made it, and we'll see you for the exam on Wednesday. Again, don't hesitate to find me during office hours. Love to talk with you.